Students, today we are going to see how the electromagnet is used in an electric bell. What is the use or how a electric bell works. And this electric bell is the most common used application, and every house has got an electric bell. Now before we start, we will first go through the construction and the wiring. Now we will see the main parts of the bell. Concentrate on the figure that you can see over here. The first part is a horseshoe electromagnet M, which is having a soft iron core. Now see the figure. Can you see the electromagnet in the horseshoe shape? Fine. Next you can see a soft iron armature A. See where there is A in the figure. Armature, it is labeled also. On the left side, armature is labeled. See the line where it takes you. A is written. You can see a thick line, that is the soft iron armature. Then there is a hammer H. Search for the hammer H. See outside the bell you can see a small circle and then this gong. Okay, just next to the gong, that is your hammer. Okay, H is written over there. Then there is a gong G. The bigger circle what you can see, this is the gong. Now when this hammer hits the gong, we get the noise. Then you have a metallic strip SS, CSS, metallic strip, that is just next to A. Just next to A. A is that fully colored thick line, and after A you can see a strip, that is SS. Then you have got an adjusting screw S dash, CS dash, just above the SS, below the hammer S dash. This is a screw. Adjusting screw, we can turn it to make it tight or loosen. Then you have a switch bell, switch or a bell push K. See in the circuit bottom, battery के बाजू में देखो एक switch है K, and then you have a battery. So these are the 8 parts of the electric bell. Okay, now how this works. Now this armature A is fixed to the spring SS. You can see A is fixed to SS. They are sticking to each other. And hammer H is attached to the upper end of the armature A. Armature A देखो straight जा करके it is having a turn and going to the hammer H. So the hammer H is actually connected with the armature A, upper end. A normal position when the switch or the bell push is not pressed, मतलब जब switch off है, then the strip SS makes contact with the adjusting screw S dash, and there is a gap between the armature A and the ends of the electromagnet. Now when the switch is off, what happens? SS is in contact with S dash. देखो यहाँ पे कैसे touching है. Okay, SS is going to touch S dash. And what will happen in that? If it touches S dash, आर्मेचर ए और इलेक्ट्रोमैग्नेट का जो दोनों एंड है, दोनों के बीच में गैप हो जाएगा. ओके, देयर इज अ गैप बिटवीन द आर्मेचर ए एंड द एंड्स ऑफ द इलेक्ट्रोमैग्नेट, because it will be now touching that in the off position. SS is going to touch the screw. Now there is a coil CC which is wound on the arms of the electromagnet. देखो इलेक्ट्रोमैग्नेट के दोनों आर्म्स में हमने वायर डाला है. अब वो वायर के थ्रू उसको इलेक्ट्रिसिटी आएगा. ऑन वन एंड ऑफ द कॉइल इज कनेक्टेड टू द टर्मिनल T1. एक एंड देखो, सर्च फॉर टर्मिनल T1. देर आर 2 टर्मिनल्स T1 एंड T2. देखो एक सर्कल मार्क, एक डॉट के बाद एक बड़ा सा सर्कल दिया है उन्होंने बॉटम में. T1 एंड T2, दीज आर द 2 terminals where we are going to attach the wires. बैटरी से वायर ये टर्मिनल्स में आएंगे और फिर बेल से भी वायर उस टर्मिनल में जाएगा, so that the circuit is completed. So T1 में क्या जा रहा है? From this, which one? From the S dash screw. Okay, S dash screw से एक वायर आ रहा है जो टर्मिनल T1 पे जा रहा है, और उसका जो अदर एंड है दैट इज कनेक्टेड टू टर्मिनल T2. और टर्मिनल T2 में क्या आ रहा है? सी, ये जो Okay, again see the connection, see the horseshoe magnet. Horseshoe magnet में we are winding the wire. Now that wire, one end of the wire near the A, you see one end of the wire is going to that metal strip SS, okay, and SS is contacting what? S dash, and through S dash it is coming to terminal T1. So one end of the horseshoe wire is connected to T1, but not directly. We are not connecting the wire directly to T1. It is coming to T1 via the SS strip and via the S dash screw. And the other end of the wire, or the other arm of the horseshoe magnet, you can see directly in the blue color, it is coming to the terminal T2. Okay. Now how we will see how does it work. Now this is based on the working of the electric bell is based on the magnetic effect of the current. Now when the electric circuit is closed by pressing the switch K, अभी तुमने switch K को क्लोज कर दिया, सर्किट क्लोज हो गया, करंट फ्लो हो रहा है, देन व्हाट विल हैपन? करंट विल फ्लो थ्रू द कॉइल CC ऑफ द कोर ऑफ द इलेक्ट्रोमैग्नेट. वो कॉइल में करंट फ्लो होगा. अभी आयरन कोर है यू शेप में, तो ये क्या बन जाएगा? ये मैग्नेट बन जाएगा. सो व्हेन इट बिकम्स अ मैग्नेट, व्हाट इट विल डू? इट विल अट्रैक्ट द आर्मेचर ए. नाउ द आर्मेचर ए विल गो एंड स्टिक टू द horseshoe magnet. Okay, now because of this, when A is going to come and stick to the electromagnet, A के साथ कौन कौन जाएगा? वो हैमर भी जाएगा ना, हैमर भी कनेक्टेड है A में. So when A moves towards the electromagnet, hammer also moves towards the gong, and hammer is going to strike the gong and the bell rings. लेकिन उसी समय क्या हो जाता है? जब आर्मेचर जो है मूव होता है टुवर्ड्स द इलेक्ट्रोमैग्नेट, कनेक्शन बिटवीन द स्ट्रिप SS एंड SQ ब्रेक हो जाता है. करेक्ट. अब ए अगर इधर हॉर्सशू मैग्नेट के पास में आएगा, हैमर भी उधर जाएगा, तो ए और SS के बीच का कांटेक्ट, अभी फिगर में ए और SS चिपके हुए दिख रहे हैं, दे आर इन कांटेक्ट, लेकिन अब ए जो है थोड़ा सा इलेक्ट्रोमैग्नेट के तरफ अट्रैक्ट होगा. सो देयर विल बी नाउ अ गैप बिटवीन SS एंड ए. नाउ देयर इज नो कनेक्शन बिटवीन ए एंड SS. ओके, सो व्हाट हैपेंस? द सर्किट ब्रेक्स. सर्किट ब्रेक हो जाता है. Now because the circuit breaks, what will happen? Now current will not flow in the electromagnet. It will no longer be a magnet. फिर अब वो ए को अट्रैक्ट नहीं करेगा, ए वापस अपनी जगह पे आ जाएगा, हैमर फिर से दूर हो जाएगा, अब आवाज़ बंद हो जाएगी. इट विल नॉट रिंग. बट मोमेंट दिस हैपन्स, तो क्या होगा? ए वापस चिपक गया SS के साथ, अब फिर से कनेक्शन बन जाएगा. अगेन द सर्किट इज क्लोज, अगेन द करंट विल फ्लो, अगेन द हॉर्सशू मैग्नेट विल बिकम अ magnet, again it will attract A, again A will go towards the horseshoe magnet, again hammer H will go and strike the gong, again the bell will ring, again the gap between A and SS will be created, again the connection will break, again the current in the circuit will stop, again the electromagnet will not be a magnet anymore, it will not attract A. So A will come back to its position and stick to SS. The moment A sticks to SS, again the connection is done. Again the current flows through the electromagnet. Again it attracts A, and again the hammer H strikes the gong. So this is repeated and you get a continuous ringing of the bell. So continuously the process is making and breaking, and the hammer is striking repeatedly, and the bell rings as long as we keep the switch K pressed. So this is very simple how the bell works. I am very sure it is clear. After this video, read it from the textbook, and if there is any doubt, please post it. Now there is a note that in an AC source is used in place. Suppose instead of this we use an AC source, then what will happen? The core of the electromagnet will get magnetized, but the polarity at its end will change. Since attraction of armature does not depend on the polarity of the electromagnet, so the bell will still ring on pressing the switch K. Now for the bell, instead of battery, you can connect it to the AC source also. It will not make any difference. Why? Because वो AC में क्या होता है कि डायरेक्शन चेंज होता है, तो नॉर्थ साउथ चेंज होता है, लेकिन उससे क्या फ़र्क पड़ता है? वेदर इट इज़ नॉर्थ इधर है या उधर है, इट इज़ स्टिल गोइंग टू अट्रैक्ट द आर्मेचर ए. हमारा काम क्या है इधर इलेक्ट्रोमैग्नेट का? टू अट्रैक्ट ए. अभी तुम्हारे पास इफ़ यू आर हैविंग अ मैग्नेट, whether the north pole is this side or this side, it is still going to attract the pieces of iron. So here in this case of a bell, it makes no difference whether you are Sorry for the technical error. So whether it is an AC source or DC source, it doesn't matter. Any source can be connected over here, because our purpose is to just make the electromagnet a magnet and attract the armature A. So whether it is the north pole or it is the south pole, it makes no difference. It is going to attract the A. So this completes your unit and the working of electric bell.